Welcome back to Chapter 11. In this chapter, we are going to be looking at surveys. Now, surveys is something that you probably already know something about, partly because you've probably seen it a little bit in some of your other classes from time to time, and partly because surveys are everywhere in the world, and so we see them all over the place for all sorts of different things. Um, I mean, we're just now getting out of the 2020 election season in theory. And so, like, we've been seeing a plethora of surveys all the time, wherever you look, some good, some bad, things like that. So we've seen surveys. We know what surveys are. Um, we're going to look at some good methods. We're going to be looking at some bad methods and things to avoid, and looking at some vocab and notation as well. So, our learning target for today, and this is a good one, analyze sampling strategies. hmm So, what are some big ideas about surveys? The first one is a survey. We're going to examine a part of the whole population. Um, the population is the whole group of interest. Now, it could be the population of the planet. It could be the population of the state of Washington. It could be the population of Stanwood. It could be the population of Stanwood between the ages of 18 and 25. If that's the group of people that we are looking to describe, that's the population. It could be the students at Stanwood High School. It could be the seniors at Stanwood High School. It could be the senior males at Stanwood High School. It could be the boys basketball team at Stanwood High School. It could be boys basketball teams in the state of Washington. So the population can take on many different looks, but again, it is the group of individuals, usually people in a survey, um, but so the group of individuals that we want to say something about, that we want to generalize. So that's what the population is. The sample is the part of the population that actually gets studied. Generally speaking, we're not going to be asking the entire population questions. I mean, that's always nice when we can do it. We'll talk about that in a little while. But usually that's not going to be feasible. Um, I mean, if we have the students at Stanwood High School, could we ask every single student a few questions? We probably could. It would not be the easiest thing, but we could probably do it. Stanwood High School is not very big. If you think about residents of Stanwood itself, could we ask everybody who lives in Stanwood a few questions? Probably not. All of a sudden, that becomes a lot more difficult. And so the bigger the population is, the harder it is to ask everybody. And that's why we choose a sample. Um, and so the biggest part of doing a sample survey is to reduce bias. Now, bias has a few different meanings that are all kind of similar, but not quite. This isn't the bias that you hear about on the news most of the time. Bias in statistics is systematically favoring one answer or one result, whether it's purposefully or accidentally. And that can happen in a variety of ways that we'll talk about. But the people who we ask could introduce bias into our survey. Um, the way questions are worded could introduce bias into our survey. Um, who's asking the question could introduce bias into a survey. That sounds a little bit weird, but if a uniformed police officer is asking you questions about drug use, let's assume that you use drugs. I'm not saying you do, but assuming you did, would you be more or less likely to answer honestly to this uniformed police officer? Probably we would see a lot less drug use in this survey than if it was a random person asking, or if it was like an anonymous internet thing. Um, so the person asking could introduce bias. Um, and the idea in our survey is to try and reduce it. And so that's what we're going to be talking about for most of today, is ways of reducing that bias, um, either implicitly or explicitly. Big idea two, randomize. That's one of the big ways that we reduce bias. We want to randomize who we're selecting, and we can do this in many different ways. And we're going to be talking about the different ways of setting it up, different ways of doing it. The big ways of randomizing are using random digits and random number generators. So that random digit table that we saw in the last chapter, that's going to be back. Random number generators, things like that. Um, I randomize the cars for the local soapbox derby, how like where their starting position is in the bracket. Um, and I do that simply by drawing names out of a hat. That is a randomization method. Now, if you had a like thousands of people in your population that you had to randomly pick, you wouldn't want thousands of cards and thousands of names in your hat. That that would not be a um, it wouldn't be something that you'd be able to take to larger numbers, but for the small number I have that I'm working with, that's a legitimate method. And ideally, though, when we do take a sample, we want it to look like the population. And that's not look like if we physically look at them, that would be using like all the variables that we can think of. We want our sample to be representative of the population in all those variables, especially the ones that we're concerned with in our sample. Idea three, the sample size. The sample size is hugely important. And in the sample size, bigger is better, generally speaking. We do need to stay less than about 10% of the population. Not that asking more people than that would be bad. It's just that the formulas and stuff that we'll be using throughout the rest of the year, um, they they kind of break down a little bit. Again, not in a bad way necessarily, but we would get different numbers. And that is due to the sample variability that we'll talk about a little bit later. The more people you ask, the closer it gets to the population, so you have less variation in there. And so you just have to deal with that a little bit. And with the sample size, it doesn't matter what percentage of the population it is, assuming it's less than 10, it's the actual number of people. The idea is if you have a like giant silo of corn and you take a scoop of corn out of it, it's the size of the scoop that really determines what you're dealing with, not how big of a pile you're taking the scoop from. It's a weird analogy, but it's one that's actually fairly commonly used. I'm not entirely sure why, because yes, we understand that corn goes in silos, being that we live in Stanwood, but a lot of people don't necessarily get that. Um, and then if we sample the entire population, that's called a census, not a sample. I mean, the census comes out every 10 years. They try to get the entire population. They don't quite, they always miss some people, but they do try to get everybody in the nation. The reason why we usually go for samples instead of censuses is that a census is generally very, very expensive and very time consuming. It is not an easy thing to do. That's why as a nation, we only do it once every 10 years. Um, and so, again, like, could we sample all of Stanford High School? we could probably get pretty close to that. Again, it's not going to be super easy. Could we sample our entire class? Yeah, we could do that pretty easily. That wouldn't be all that hard. I mean, there's only like 30 of us. But to get to the whole high school, that difficulty level gets quite a bit bigger. If we go to just Stanwood, all of a sudden that difficulty is like way bigger. How about everybody in Washington? I mean, that's not something that we're going to be able to do, and that would be difficult for like a government level even to do. So uh, that's why we don't do censuses. We get a sample that is indicative of the population, hopefully. So populations and parameters. Um, we have populations. The variables, the pieces of the population, those are called parameters. Like the population mean is a parameter. The population standard deviation is a parameter. The population proportion is a parameter. As opposed to samples, the stuff we get from the sample, those are called statistics. So the sample mean is a statistic. The sample standard deviation is a statistic. The sample proportion is a statistic. Now, I wish there was an easy way to remember that the population has parameters and samples have statistics, but I can't quite get it. And so if you guys can think of something, that's awesome, but to try and remember that populations have parameters and samples have statistics, I don't know. It's just kind of weird. Just one of those things you have to remember. Um, but they have different variables. For instance, the mean. In our samples, we had a mean was X bar. In our population, the mean is mu. A sample, we had standard deviation. It was S. The population, it's a sigma. Generally speaking, we'll find that the population parameters are Greek letters, whereas the sample statistics are English letters, or they have weird things on top, like the X bar, P hat, the proportion. We get P hat versus just P for the population. I know that's just an actual letter, but it doesn't have the hat on it. So we get those. Um, a great table in the book is this, and I love this part. You know, they give you notation alerts and stuff when you're reading. This notation alert, the entire table is a notation alert. I love it. There's so many little things about this book that I love, including so the pronunciations for like the regression coefficient down here. It's either B or beta, which is pronounced beta. Footnote: if you're from Canada or the UK, they pronounce it beta. Okay. Proportion: P hat or P, pronounced P. Footnote: just in case you weren't sure. Like, I mean, yeah, I love it. Um, so rho, the correlation. Statistic is R. The parameter is rho, which is another Greek letter. We don't usually deal with the correlation of the population. And the thing with the population, the parameters, is that no one knows this stuff. We can make estimates, that's where we get our statistics, but nobody really knows what those population parameters are. If we did, we wouldn't have to find a sample. We wouldn't have to do that stuff. So, um, and it's Greek letters because nobody knows. Well, but Zeus knows. So, you know, and Zeus would write in Greek. So there we go. And sometimes it's even unknowable. Like you can't figure out what it is. Some sampling methods, and these are good sampling methods. The simple random sample. This is the basic sample. In fact, all the other good sampling methods involve a simple random sample. This is abbreviated SRS. There will be other ones that have the same initials, but none of them get an abbreviation. Only the simple random sample gets an abbreviation. And this is acknowledged on anything. If you're writing something statistically and your reader is somebody that is expected to know something about statistics, aka a statistics teacher or a grader for an AP statistics test, they know exactly what SRS means. And what it is it gives each group the same chance of being selected. So each possible group of individuals get the exact same chance of being selected. This is the equivalent of names from a hat. Put everyone's name in a hat. If we need a group of 5, we draw out 5 names. Every individual name has the same chance of being drawn. And then any group of people, like we could get person 1, 2, 3, 4, and 5. That's a simple random sample. The lottery is a simple random sample. We get 5 or 6 numbers depending on which lottery you're playing. And so that's a simple random sample. Generally speaking, though, we don't usually draw names from a hat because you'd have to have all the names written on pieces of paper that were the same size and shape, and then you'd have to put them into a hat that was big enough to hold all these names. And so it's just not really feasible. So usually we'd use a random digit table or a random number generator. So to do this though, to get an SRS, we would take our sample frame, which is a list of individuals from which a sample is drawn. Ideally, that is the population. It's not necessarily the population, though. Hopefully it is. Maybe it's not. For example, if we wanted to get a sample of people from Stanwood High School, we could take all the first period rosters and use that, then randomly select people from that. Well, that's our sample frame. That's what we're randomly selecting people from. We're missing people that don't have a first period class, whether they choose not to, whether they're running start, whether, like, whatever the reason, we miss people without that first period class. So that's where the sample frame is different than the population. Again, ideally we would want it to be. So all right, so we can't do the first period. Well, hey, let's take the yearbook from last year and just use the yearbook. All right, well, we're missing people that moved in that were just left out of the yearbook by error. And so there are ways, or there are people there that wouldn't be represented from the population. But to do an SRS, we take our sample frame, which is, again, hopefully the same as the population or really close to it. And then we would number everyone. We give them a list of numbers. And then we would use our random digit table. So in Stanwood High School, we have over 1,000 people, so we'd need to use the random digit table in chunks of 4. If you get the same number twice, you just skip that one and keep going because you don't want to sample the same person twice. But you would just go from a randomly selected part of the table until you had your sample size that you were looking for. And then sampling variability, I had mentioned earlier, what sampling variability is how the results of your survey will change based on who is in your sample. So if you select a different group of people, you're going to get slightly different results. That's a sampling variability. Ideally, if there's no bias in the survey and the sampling method, your results would be identical every time. But that's not going to happen. There will always be some variability. If you sample 5 people and 3 say yes, 2 say no, well, the next 5 people you sample, maybe 2 say yes, 3 say no. That's just one person with a differing opinion. I mean, maybe it's a 50-50, like maybe it's 50-50. We don't, like, it's perfectly dead even, but you can't get 50-50 with 5 people. So even if there's no bias, you'll still get slight variation in your sample. And that's okay. That's the sampling variability. That's why when we get a sample, we don't say that this is what the population says. We'll end up saying that this is what the sample says, and later on this year, it'll be, we're 95% sure that the population is going to be in this range. And so that's just all that. Again, it's not a bad thing. It's just a thing. The next type of sampling method is a stratified random sample. So for this one, you would put all the individuals into groups of similar individuals, and then you would choose an SRS from each strata. So a simple random sample, if we chose Stanwood High School students, and let's say we chose 40 of them, it is possible to get absolutely 0 seniors. Do you think that the seniors might have a different opinion or different thoughts on topics than freshmen do? It's possible. It might depend on the topic, but it's very possible that seniors will answer differently than freshmen. Or, out of our 40 people, maybe we get all girls. Might guys have a differing opinion on the topic? Yeah. And so that's where the stratified random samples come in. The groups that are similar. We could make guys and girls, and we could just do an SRS of 20 of each. Or we could split up the grade levels, freshmen, sophomore, junior, seniors, and do a simple random sample of 10 from each group so that each group is represented. Now, if we had, say, twice as many freshmen, we'd probably want twice as many freshmen in our sample as well, so that it's still indicative of what the population is. But that allows us to do it. And then we can even have each group split up, and so we can compare group results in addition to the overall results. So that's a stratified random sample. We could be breaking them up. I'm going to say age level. Age level. As opposed to like class, just age. So that's freshman, sophomore, junior, senior. Now a cluster sample is one that is used more for convenience purposes. We'd break people up into groups that all of the groups look kind of like the population. And then we would randomly select a number of groups and then just survey the whole group. So a cluster sample could be, we choose we have all the groups split up in their classes. And so we can choose to sample my 6th period class and the 6th period PE class and a 6th period science class. Like, we're just randomly choosing classes. And then you sample everybody in each of those classes. Now, just choosing classes doesn't really work out too well, because are the students in AP statistics a good representation of the population of Stanwood High School? Not particularly. You guys tend to be achievers, if not overachievers. You have been successful. More often than not, you're upperclassmen. And so you guys and, say, a group of remedial English students or pre-algebra students are probably going to have differing opinions on a lot of things, or different views on a lot of things. And so, like, just random classes wouldn't be a good choice. But is there a class setup where it is a random selection from the population? And the answer is yes. Advisory classes. Now, I know that in the past couple years, we do have those couple link crew classes pulled out, and that does change things a bit because those students would be kind of like the honors advisory students. Um, but especially before that, like the advisory classes are a random group. Now, if I was choosing a like groups from Stanwood High School, if I was going to do a survey of groups from Stanwood High School, I would probably do a multi-stage sample, which is combine some stuff. I would group all the classes into advisories, and then I would randomly select a few advisories from each grade level. And then during advisory, I go to advisory, I sample the entire class because that's how the cluster sample works. The stratified was I made sure I got each grade level. And so that makes it more convenient than if we had a list of all the students and we randomly chose 200 students, we would have to track down those 200 students to administer a survey. Advisory to or split them into grade levels, 2 advisories per grade level. That'll get us about 200 students. Maybe we do 3 advisories per grade level. And then that would be just 12 different places we'd have to go. Everyone would come right to us in those locations, and we can get the surveys administered. A systemic sampling is another sampling method that we don't see quite as often. That would be um, if we assigned each individual, like just put them in row, like in order from like alphabetically or whatever order we wanted. And you could be all right, everyone stand against the wall. And then I go 1, 2, 3, 4, 5, you, 1, 2, 3, 4, 5, you, 1, 2, 3, 4, 5, you. That would be systemic. The idea for the randomization is we would want to randomize which person we started with, not which, um, not how many we choose, because how many, like I'm choosing every fifth person, is going to be based on how many I want. I want a sample size of 20. I have 100 people. I need every fifth person. It's do I choose the first person, the second person, the third person, the fourth person, or the fifth person from each group? And so we'd randomize that. It's like, oh, we choose the third person from each group. So not you, not you, you. 1, 2, 3, 4, you. 1, 2, 3, 4, you. 1, 2, 3, 4, you. And so that's a systemic sampling. It's not a SRS because the people that you are standing shoulder to shoulder with, you're not both going to get chosen. Like, so every possible group doesn't have that same chance. If it if it's probably random. If however it's organized doesn't have any effect on the results, it can still be random. It can be a pretty quick and easy way to get a decent sample. So a survey, a valid survey. There's lots of stuff in surveys that can go um, right or wrong and things to think about. The first thing, what do you want to know? That way you can focus your questions on what you actually want to know. You can ask the people that you want to ask, like so you can focus down your population. Um, but knowing what you actually want to find out is important, and that should make sense. Like you don't do a survey just for the sake of doing a survey. Choose the correct sampling frame. Try to make it really close to the population of interest that you are looking for. Be specific with your questions. I know you've all taken surveys and like vague questions are asked. It's like, well, what about this? What about this? What about this? Be very, very specific. I know in the book it says instead of asking how much you sleep on average, how much did you sleep last night? You'll get some weird answers, but overall you're going to get better data. Keep it short. When you have too many questions, people tend not to finish. So you want it short. It needs to be enough questions to cover what you want to know, but don't have a lot of extra fluff in there. Um, as you guys know from taking a variety of different surveys, if you guys are part of the Healthy Youth Survey group, which is like every other class, um, that's a super long survey, and I know for a fact that the answers at the beginning of the survey are a lot more truthful than the answers towards the end of the survey, because as you've been taking a survey for at least an hour, you're kind of done with the whole survey stuff and you're just filling in answers. Ask for quantitative results if possible. When you have, how much did you sleep? A little, a lot, medium? Well, I slept a lot last night. I got like 5 hours of sleep. That might be a lot for me. That might not be a lot for other people. So having actual quantitative results is a good idea. Be careful in the phrasing of the question. How you word a question can seriously influence the responses, which is adding bias. Um, so if you add extra information to the question, that can um, change things. Years ago, when I first started, Thursdays were curricular days, where school would start at 8 instead of 7:40. And obviously, we don't have it anymore. There was a survey that came out from the school that asked the question, considering that most of the discipline problems happen during this curricular time, would you be in favor of getting rid of it? The answer there that most people said was no. I was really irritated by this survey because it was a very not misleading question, but it added huge bias. If instead we asked the question, considering that these 20 minutes on Thursday is the only time some students can be at school to ask their teacher questions and get help, would you be in favor of getting rid of, or would you be in favor of keeping advisory? You would get very, very different results from that question because of that extra information that was added. And so extra information can easily sway the results of a question. Think about all of the surveys and all of the questions you've seen in the, well, any presidential election season, but specifically the 2021. I think that's the thing I'm most annoyed about in the whole process, was that the surveying, the polling got so bad and so misleading that a lot of people aren't trusting it anymore. And that's worse than either outcome of the actual election. So be careful in how you phrase the questions. Also be careful in how you phrase the answers. Because if you're giving people options to choose from, which you will generally get not necessarily better data, but easier to use data if you give people options, um, you want to make sure that the options aren't leading people into a certain way or keeping people out of a certain um, answer by making the answer seem obvious or something like it draws people to it. So then we have some big mistakes to watch out for as well. First one, sample volunteers. You never want to get volunteers to answer your sample. I know that people get confused with this because the next chapter is going to be about experiments. And you can get volunteers to do experiments. but not for sample. When you do, it's called a voluntary response sample, and you get voluntary response bias. This is generally people with strong feelings on the topic, usually strong negative feelings. Think about any kind of customer satisfaction thing. Think about customer reviews on Amazon. A lot of negative reviews. Why? Because when you order something, whether it's from Amazon, whether it's at a restaurant, you go to a restaurant, you have a pleasant experience. Nothing big happens. Your server was with you in a timely fashion, takes your order's correct, the food is what you ordered, it's good. Um, you pay and you leave. Are you going to sit down and take the time to write a review? You get something from Amazon. You order, like I order stuff, like way too much stuff, but I get stuff all the time. Shows up, it's exactly what I thought it was going to be. Showed up on time. I mean, I don't think about going in and writing a review. Well, actually, I do to try and counteract this bias a little bit, but that's because I'm a statistics teacher and a little bit unusual. Um, but the people that do, it's when your service at that restaurant was bad, or the food came out wrong, or it was overcooked, undercooked. Your Amazon order showed up, it was wrong, it was 3 days late. Or in my situation, instead of putting it in my covered porch in the box on my covered porch, they put it way over on the other side of my house in a puddle next to my generator while it was raining. Yeah, I mean, that they got a review for that one, definitely. Because I was supremely irritated. And so I took the time to make sure I wrote that review because I had very strong, very negative feelings. And so that's the problem with sample volunteers. You get that. One of the most famous examples was Ann Landers. It was like the Ask Ann column. She has this column and she asked her people, just whoever is reading, to write in and say, if you had to have children, or so parents, if you could do it all over again, have kids, would you do it? And it says over 70% said no, no, they would not have had children. Which, to all of you people who have parents out there who are in fact children, that might come as a bit of a shock. It's like, holy cow, are my parents part of that 70% that would not have chosen to have children if they had to do it again? Well, that was a voluntary response survey. It was done again, and this was huge. Instead of the 70%, and it was 10,000 people who replied, they did it. 90% of parents actually said yes, they would do it all over again. They liked having kids. They liked that experience. But that was with a well put together survey instead of the voluntary response. Voluntary response is one of the biggest mistakes that people make doing surveys, either on purpose or on accident. Another one is sampling conveniently, using a convenience sample. So with a convenience sample, you just sample whoever is around. The people standing outside of Hagen's doing a survey, that's a convenience sample. So the people standing outside of Hagen's doing a survey is a convenience sample. It's nice, it's easy, you just stand there and people come to you. The problem is you get people it's convenient, which is not really the entire population. Like, you don't get the people that are shopping at QFC. You don't get the people that go out of town to do their shopping. And then in addition to that, you get people who you want to actually sample. Like when I'm coming out of Hagen's or another store, sometimes I get asked, sometimes I don't. Sometimes when I see people there and I just don't want to take the time, you don't make eye contact. You don't get asked very often at that point. But I mean, usually, like, I'm a relatively unthreatening person coming out of a store. I am not a mother dragging 3 screaming children with her. If I'm walking out of the store and someone with 3 screaming children are walking out of the store, and you had to pick one of us to ask a question to, are you going to stop the person with the 3 screaming children and say, "Excuse me, ma'am, can I please have a minute of your time?" Probably not. You are not going to get that person's opinion in whatever survey you're doing. And even if you did stop them, are they actually going to stop and answer your questions? Probably not. And so that's just one example of how you'd pick the people who are convenient to pick. Um, and so yeah, you just don't get the entire population. So convenience sampling is not a good option either. Internet surveys. Internet surveys are great, and I mean great because they are absolutely worthless. Oh my God, internet surveys are a combination of convenience and sample volunteers that they are like not worth anything. So I love it when people post internet survey results. It, oh, yeah, those are the absolute worst. There was a great internet one, like they asked how many people who have a computer at home use the internet. They asked on the internet, and it's like, well, um, as you can imagine, the results are pretty high. Everybody uses the internet. It's weird. Mistake 3 is using a bad sample frame. You always want to try and get it to be as close to the population as possible. Otherwise, you miss parts of the population that could be specific parts. For example, if you're using the phone book is what we used to use to know people's phone numbers, like everyone's phone numbers were listed. But nowadays, if were using a phone book, you would miss people that don't have landlines because cell phones aren't listed. So you'd miss people that don't have landlines. People that don't have landlines tend to be younger people, like people in their 20s, um, and they might have a different opinion than the rest of the population that you would be asking. And so, um, making sure you have a good sample frame is huge. And that can take a little bit of thought sometimes, like thinking like, who am I missing in this? Like, and you have to be a little bit creative. And what that leads to undercoverage. Undercoverage is simply not getting a representative proportion of certain populations. Either getting nobody because of perhaps a bad sample frame, or sometimes undercoverage just happens because of the randomly selected individuals. If we're selecting um, the students at Stanford High School and we're selecting 40, and we only get one senior just because of the random choice, that's undercoverage. There wasn't really any way around that other than using a stratified sample or something like that, but um, that is undercoverage. It could also be um, it could also be more of a systemic problem that we could deal with that just has to do with the sample frame. But undercoverage is just either completely omitting or having a lower proportion of a certain part of the population in your sample as from your population. Couple other pieces of bias that we could get. Non-response bias. These would be the people that don't respond. Um, They don't respond to the survey. So if you select you're dealing with standard high school, and you split them into advisory groups, and you split them into classes, and you got 2 advisory classes from each grade level. The freshmen are going to be there. There's going to be like 27 of them in each class because they all show up. Seniors, not so much. You're going to get a lot less responses from those seniors who are skipping their advisory classes. And are the seniors skipping their advisory classes going to answer differently than the freshmen who are all there? Possibly. And so that non-response bias is from those people that just don't respond. If people are doing a telephone survey, they randomly select telephones across the nation, and they're calling. It's like, the non-response would be the people that don't answer the phone, or the people that answer the phone and then just choose not to answer the survey. Those people may have different responses than the people that answer the phone and then participate in the survey. And so that's what non-response bias is. The other one is response bias. No, these aren't opposites of each other. A response bias is how the response it's the bias in the response. It's leading it towards one choice or the other. That would be like the wording of the question is leading you towards one answer and things like that. So the non-response is people that don't actually respond. The response bias is pushing the answer towards one towards what you want to hear, basically. And then how to think about biases. Look for biases in every survey that you encounter. That is what you are doing, and surveys that you see in the news, and things like that. Like, don't trust anything. Always look to see how is it done. Are these results good? Or are they not good? One of the things about statistics that we learn, like, it's not just how to do it, but how to recognize bad stuff and be able to think logically and think for yourself on what you trust, what you don't trust. So look for the biases, especially if something shows up and it's just kind of unbelievable. See, how was that survey conducted? What was it? And that can be really quite enlightening. Um, and then there's a great quote that I heard years ago. There are no special formulas or computations that can fix bad data. So without good data, if your survey is biased, there's nothing you can do with that. Another quote, which is a little bit more common, a little bit shorter, but says basically the same thing, is garbage in, garbage out. You have bad data, you're going to give bad results. There's no other way around it. You can't fix bad data. So look to see if there's bias in the survey to see if the data that they're making their decisions from is good data. Spend your time and resources reducing bias. When you are doing a survey, that is the most cost-effective thing you can do. Reduce your bias, because again, there's no fixing bad data. So spend a lot of time to get good data, even if it's less good data. If you get a lot of bad data, that's just an even bigger waste of time because you use more time to get garbage. And so make sure you can get good data. Think about the parts of the population that could have been excluded from the study. This is specifically when you're looking at the sample frame. That way you can get that fixed before you get your data. But again, like I mentioned that just a minute ago, like there's a bit of creative thought that goes into this part. Pilot test your survey if you can. Once you get your survey done, give it to a few people, ideally from the population that you're looking at, just to see if you get some really weird answers or things are confusing that you didn't think were confusing or things like that. Like if you can, it's always a good idea to pilot test a survey. Um, and then always report your sampling methods in detail. Um, if you don't, specifically, if you are a big sampling group that's giving out like big national samples and poll results, one of the things that I'm looking for when I'm looking at a survey is sampling detail. If you give me some detail, like some results, some sample results, like, oh, 42% of people say this, and you include no details on how you got that, that's not a survey or data. That's an opinion. That's your opinion. Unless you have the data, unless you have the how you got that data, then the validity of whatever you're doing goes way down. So you always want to report your sampling methods in detail. Um, and so I know that like a lot of times, like newspapers, news, they don't have the time to report in detail or the space, but they should always link it so you can go to the study that was actually done. These studies are published in like multiple pages that give all sorts of stuff. You will be reading one at some point in the near future, so you can look forward to that, and it'll be awesome. So that is all about sampling. Tons of stuff about sampling. Sorry for the length of it, but sometimes it's just what has to be done. Make sure that you read the chapter. There's a lot of good details in the chapter and good examples that I did not have the time to discuss today. I went over main parts and to try and get you a little bit extra. So read the chapter. Other than that, I will see you in class. But until then, keep working problems, keep asking questions, and as always, happy mathing.